Hello friends, welcome to my new channel where I will be explaining the robot I am building and the parts associated with it. So I'll be showing you what model I am building with. So let's start quickly with the chassis. So here is this TS100 chassis robot. Now regarding power management, I am using these lithium ion cells. For this robot I have salvaged some old batteries from mobile power banks and old laptop batteries. So I just recycled them. Battery control, since this is a lithium ion battery, we'll be using a special charger for this, and these are designed especially for lithium cells, lithium ions and lithium polymer batteries. Now for again power management, we'll be using these glass blast fuse. So what this does is this comes with this module where you can insert this glass fuse inside it, and here you see that there are some ratings mentioned for each category. So for example, this is rated at 4 amps. So if the charge increases, if the current increases more than 4 amperes, this this fuse will blast and it will stop the power current flow. So your components will be safe. Now for computers using in this project, I am using two SBCs, which stands for single board computers. So I'm using two SBCs over here. One is the Raspberry Pi model 3B plus, which soon I'll be upgrading with Raspberry Pi model 4B, and this is the ASUS Tinkerboard model. Now for microcontrollers, I'll be using one or two Arduino Mega, since our project has many input output requirements for many sensors. So we'll be using two or one Mega. Instead of Arduino Uno, we'll be using two Arduino Nanos. A Nano is very similar to Arduino Uno, just that this has some benefits, like it has some more pins, some more input output pins and some more analog pins. So this is a much better board than Arduino Uno, as it takes very less space. These are a couple of display I am using. This is a regular display with I2C adapter, and this is also an I2C adapter, but this is OLED display. So this is that. Now for power management, I am going to use a couple of buck converters. So this is 10 ampere rated buck converter. So as you saw, this is 3.7 volt per cell battery, and if you combine this for 12 volt, your output volt will be around 14 to 16 volts. So in order to regulate it to 12 volts, as for our robotic motor, we are going to use this gear motor, and now the one which we are using in this tank, that is rated at 12 volt and 691 rpm. So for 12 volt, we will be giving this will be our main power chip, which will be controlling the output of the battery and regulating it into 12 volt constant current supply. Now after that, we have couple of more buck converters. So for Arduino Nanos and Arduino Mega and all the other sensors, which generally take around 5 volts, that is the maximum. So I'll be using this buck converter. And for our this servo motors, which we are using in our robotic hand, so we'll be using this buck converter, and this buck converter will be used for around 6 to 7 volts. So that is that. And one thing I wanted to show you, so this is my robotic hand, and as you can see the rating over here, so this is 20 kg Newton centimeter rated. So this is quite high torque, And as you can see, for all the servo motors there are actually three pins, three output pins, three wires are coming out of each one, but I have added one additional to all of them. I will show you an example from here. So here is a sample motor, and which comes with three wires attached. So I have soldered one wire to the uh, microcontroller chip inside this servo, which gives the output of the chassis, which is connected to the potentiometer, and it is the output of that potentiometer. So even without moving it through code, I can know the position through analog pin, which is the pin out. So this will be quite handy in our project, and I'll be doing a separate videos on making these things, so it will make things easier. So this is useful. I will explain later how it is useful in maintaining our arm. So basically we can provide input manually through moving the shaft, moving the hand, and the computer will store the values of each potentiometer from the different servo motor. So you can basically move the hand, and then it stores the values of whatever movement you have done with the hand. So it comes to that. Now talking about some sensors. So before sensors, I would like to show you the motor controllers. So this is a 12 volt 10 ampere rated controller. Actually it works from around 9 volt to 36 volt, but since we are using 12 volt, we'll be powering it up with 12 volts only, and it works regularly on 10 amperes, but it can at bursts of 30 amperes it can also work. Previously I used to work with these L298N motor controllers, but as you see, these use heat sinks, and thus there is a lot of power loss, and it is not as much as efficient as this. So I am not going to use these. Now this is PCA 9685. Now this is simply for servo motor controllers. So actually you can control 16 servo motors based on this single chip, and it uses I2C connection, and so based on 2 pins from Arduino you can control 16 motors. Now talking about sensors, I have some couple of as you can see, these are ultrasonic sensors. These are basically used for distance sensing. Also in addition to distance sensor, I have these infrared distance sensors. So these are very useful, because you see the potentiometer here, you can adjust the sensitivity of the distance being measured. So this is quite useful. And we have couple of voice sensors. So these modules can detect voice, and you can place it in such arrangement where it can pick up the sensitivity of the voice, and can know the direction in which the voice is coming from. Now this is a PIR sensor, which basically reads human body temperature and detects the presence of a human being in the vicinity. This is a joystick controller. Now this joystick controller is basically a combination of 2 potentiometers, and it gives you directional results, directional output. So one is the x-axis, or you can say forward, backward, and then there is the y-axis, you can say left or right or horizontal movement. Now we have couple of potentiometers. We have NRF 24 signal radio signal module. So this is very easy to control with a radio remote control. We also have infrared sensor over here. So you can use your TV's remote control or AC's remote control to control this robot as well. So you can program it with those remote controls, and it will work like that. So basically this was the introductory session. I will make videos of all these modules one by one and explain how it is working. So that was the video, guys. Thanks for watching my video. Please do like, share and subscribe to my YouTube channel, and for regular updates Please follow me on Instagram at the handle Waldoor, and thanks for watching.